Okay, last section of the unit, 5.7 interpreting graphs of linear functions. So just a reminder that any graph of a line that is not vertical represents a function, because of course if you have a vertical line, remember, okay, all of your x values are going to be the same, so that would not be a function. Okay, so we're going to call these linear functions. Now, grade 9 we call them linear relations, now we're going to call them linear functions. We can use intercepts, okay? So it's important that you understand what this word means. And an intercept is just where a line crosses either the vertical, the y-axis, or where it crosses the horizontal axis. And there's always something special about those intercepts, okay? So if we said that the horizontal, that's going to be your x-axis intercept, is 2, okay? So we went over on the x-axis to 2. You can see that the coordinate there would be 2 and 0. Okay, and the graph intersects the vertical axis at 5. So that's what the vertical intercept is, 5, just simply 5. But if you asked for the coordinates, you would say 0 and 5. So now if we took a look at these two intercepts, you can clearly see that the one thing that they have in common is each of them has 0 as one of its coordinates, okay? All right, so we're going to use this information and we're going to be able to graph, okay? This graph shows the temperature and the location over a 12-hour period, okay? Find the vertical and the horizontal intercepts. Okay, so if I was to find the vertical intercept, and I'm just going to abbreviate it as VI. Vertical, of course, represents the y-axis, so we're going to look here, and you can see that the graph crossed the y-axis at -6, because this graph moves in increments of 2, so -6. Now that's the intercept. Now if I asked you what are the coordinates, you would tell me, okay, that they are 0 and -6. Now, if I asked for the horizontal intercept, okay, you would tell me, I don't know why I put a negative there, it crossed the x-axis at 4, so that would be its intercept, which would be 4 and 0. Now, if you were to find me the domain and range, let's remember how to do that, x and y. The domain, okay, is going to be our x, and there are 2 endpoints. Okay, so we're going to say that x is greater than or equal to, and the lowest that x is 0, and the greatest that x is 12. So that was just a review of how to do domain and range. If I were to find my range, okay, we can see that there are clearly endpoints for our range. The smallest that y is -6, and the greatest that y is also 12. Okay. This graph shows the fuel consumption of a scooter with a full tank of gas, and that makes sense that this is going to be a negative sloping line because the further you drive, okay, the less gas you have in your tank. Write the coordinates, so that means that we're going to have this in an XY situation, okay, where the graph intersects the axes, okay? So if we were to find the vertical intercept, okay, that's where it crosses the y-axis, crosses at 8, that's a vertical intercept, therefore the coordinates are 0 and 8. Horizontal crosses at 200, therefore the coordinates are 200 and 0. What are the domain and range? Okay, there are clear endpoints for both, so we can set it up like this. Okay, I always like doing that first, and then remember, smallest on this side, largest on the other. What's the smallest that our x can be? 0. What's the greatest that our x can be? 200. Range, smallest that my range can be is 0. Greatest that my range can be is 8. And you can see that there is a connection here. I'm hoping that that's starting to come together for you. Okay, this graph shows the height of a candle burning, okay, and that makes sense that the height goes down as it burns. Write the coordinates of the axes, the vertical and the horizontal intercepts. So we start with the vertical intercept, crosses the vertical intercept at 10, so therefore the coordinates would be 0 and 10. Okay, and now if we were to do the horizontal or the x-intercept, you can see clearly here it crosses at 45, 45 and 0. What are the domain and range? Okay, and you should be able to see here that there are clear endpoints for both the domain and the range. So I always set mine up like this. It's just a personal preference thing. Okay, because I know that this is exactly the way that the inequality symbols are going to sit, and then I just have to concentrate on now what's the smallest that my domain can be? 0. Largest it can be 45. You can see clearly here. Okay, there's a connection with the coordinates and the domain and range. Okay, what's the smallest that my range can be? Is 0. The biggest that it can be is 10. Okay, now we can find algebraically, okay? So this is the graph of the linear function, and we did lots of this in grade 9, okay? When the graph intersects the x-axis, you should understand that y is 0, right? That's what we said. There's a special connection with the intercepts, is that one of the coordinates is always 0. Okay, so if you wanted to find the x, you could substitute y is equal to 0. And I'm going to show you what that looks like. Okay, we're going to take this. Y is equal to 2x minus 3. Okay, and when the x crosses the line crosses the x-axis, y is 0. So to find the x-intercept, we can simply substitute y in here. 0 is equal to 2x minus 3. Okay, we're just going to solve this algebraically like we normally would. 3 is equal to 2x. You're going to divide both sides by 2, and x is equal to 1.5. Okay, 3 halves, 1.5. Like, I really don't care how you want to say that. Okay, I just think we can more easily see this. So where does this thing cross the y-axis or the x-axis? You can see here, 1, 2. It crosses kind of in between. So 1.5 seems accurate. Okay, so now what if I wanted to find where it crossed the y-axis and I didn't have this graph? Like, I can clearly look here and say, oh, it crossed at -3. Like, that's a no-brainer. Okay, but what if we didn't have that? Okay, so again, we're going to take the same equation because that can't change. And now to find y, we're going to substitute 0 in for x. Y is equal to 2 times 0 minus 3. Y is equal to -3 because anything times 0 is 0. And if I looked over here, I could just clearly check that. Okay, so it's just more efficient when the intercepts are integers, because if I asked you to find me where this crossed the x-axis, you could guesstimate that it's 1.5, but that might not be completely accurate. Like, we might have worked it out algebraically and it was 1.4. Okay, so when we're talking about integers, when things aren't clearly crossing at a corner, then sometimes this was the way that it worked. Okay, so sketching a graph now. So now we can find the intercepts and then we can sketch it here on the graph, okay? So what we're going to do is we're going to use this equation and we're going to find the intercepts. And I've clearly done this, so we're just going to walk through it very quickly, okay? So to find the x-intercept, I could plug in 0 for y. Oh, sorry, I wanted to do the y-intercept, so we're going to plug in 0 for x. 2 times 0 minus 4. Y is equal to -4. So see, on the graph, I just put a dot at -4. Okay, that's what I would do first. And now I'm going to find the x-intercept. So what I do here now is I go 0 is equal to 2x minus 4. And I add 4 to both sides. Divide by 2. X is equal to 2. And now I put a dot at 2. And then I take a ruler and I draw a line, okay? And that's how I graph that. So we're going to do one more, I'm hoping. So now we're going to find the y-intercept. And the equation is -2x plus 6. Over here, I'm going to find the x-intercept. And you have to use exactly the same equation, obviously. Okay, so when I'm finding the y, x is equal to 0. So I plug in 0 here. Y is equal to -2 times 0 plus 6. So therefore, y is equal to 6. So I go here. And I go 1, 2, 3, 4, 5, 6, and I put a dot there. And now I'm going to find my x-intercept, and I do that. I make y worth 0. I'm going to subtract 6 from both sides. Divide both sides by -2, and x is equal to 3. So then I go on the x-axis, and I put a dot here, and I don't really have a nice ruler handy. Okay, but you take a ruler, and you just simply draw a line, and now you've graphed that using the x and the y-intercept. Okay, so there's 2 U-tries on the notes, and I'd like you to give those a whirl, and then we're going to finish these notes up, and we're done the unit.